simulation tool that'll let you actually pan through things at different size points. So as you can see, we're kind of panning smaller and smaller and smaller and smaller and smaller. And eventually you get down to the size of the atom, right there. And part of this activity has kids kind of working with exponents and kind of taking apart exponents as kind of this mathematical component. And then it's also got this kind of inquiry-based thing where they're looking at things like maybe a buckyball, a carbon nanotube, glucose, phospholipid, things they haven't heard of before. They're kind of asked to kind of fill out a little sheet of, oh, I didn't know what this is, or oh, I didn't do that. It really asks them to kind of capitulate the difference between, oh, what is 10 to the 0 and 10 to the minus 9? How many times different is that? So they kind of get this idea. And then what's cool about it is, so at 10 to the minus 9, we start to see atoms. But when we go in reverse, when we go up, and it's a lot of panning. But what will actually happen is if we go up to the other direction, 10 to the positive 9 is going to be the size roughly on the scale of the sun. So kids kind of get this idea that an atom is so small, it's basically like taking a meter and scaling it up to something the size of the sun. And then they also understand that in reverse. So it's the same as taking that meter, scaling it up to the size of the sun. And then if we shrank down that much, that's how far away an atom is from us. So it kind of helps put that into perspective. So that's the goal and the purpose of that activity. And then there's a kind of this opportunity for them to, they can go all the way out if they wanted to the size of the observable universe, or they could go all the way down to quantum foam. And then there's a little section that'll let them kind of explore with it too, which is something I like about that. And then the second activity is this build an atom simulator. It's through PhET. There's some copyrighted material, I think, but I'm pretty sure they have an education license for it. So you basically come in here, and the students are able to drag pieces of the atom into the kind of the octet shells that we have going, and it'll basically change depending on how many protons. It'll move the mass number. It'll move the atomic charge. And they can basically play with this, and if they try to do something wacky, it'll actually vibrate. Let me see if I can demonstrate that. So yeah, sorry, I didn't check the blocks, but yeah, so it'll actually have the stability of atoms, the neutral ion, all that kind of stuff. And here this kind of lets them play with different pieces of the atom itself. And then on this, there's just some basic questions that are asking them, what happens when you add a proton to the mass number? What happens to the charge when you have an unequal amount of this? What are the charge and names of atoms at certain different protons? And then they can relate that to the periodic table. So I like this tool a lot. It's pretty powerful. So from RLO, I just kind of designed a little worksheet around that that kind of helps kids take some meaning out of this, because with these cool simulations, it's really easy to just either A, on the last one, kind of pan through the universe aimlessly, or B, just kind of drag circles on there without really thinking about it. So the worksheet I have set up is kind of the scaffolding tool for the kids to use. So those are my two ROLs for this assignment, and then I'll talk more about the other one.